It's my first trip in Sweden, so a little introduction is in order. I'm Nicolas Fränkel. I'm a developer, architect, solution architect. Basically, I'm a consultant. So I'm doing what the customer wants me to, and I've been doing consulting for nearly 15 years now. I happen to work for this nice little company called SAP. I'm not working on ERP stuff. I'm working purely on Java and Spring on something called Hybris, which is an e-commerce platform. And we are recruiting, so if you're interested, there are some business cards. So the stuff today is about integration testing. And I will try to highlight the most important fact from this book, which I've written, which is a problem is, why did I write this book? Because I saw a lot of crap regarding integration of testing. Basically, unit testing, you have lots and lots and lots of book, article, blog posts, videos, anything. You can find anything on the net. It has been done, redone, redone. Everything is nice, because basically, unit testing is very simple, and it's very limited in scope. About integration testing, it's not so clear-cut. And I've talked with people, smart people, and one of them told me, hey, you know, I'm doing unit testing. Great. Can you please just tell me what do you mean by that? I'm using JUnit. And when he described me his test, it was clearly integration tests. So I've decided, OK, let's put something in written form so that everybody can have the same understanding of the semantics, and let's go a little further. So first, what is integration testing? What is testing? What is unit testing? You know there are a lot of testing flavors. You have unit testing, integration testing, performance testing, penetration testing, and you have mutation testing. At one point, I stumbled upon a website that listed nearly like 100 different flavors of testing. So it's very rich. In this talk, the scope will be much narrower. We will just have a little introduction about unit testing and integration testing. So unit testing, as its name implies, you test a unit, so you test the unit in isolation. And integration testing is testing the collaboration of multiple units. Let's take a very simple example. We have a prototype car. So if you want to unit test the car, you will test every little piece of the car separately, every nut, bolt, screw, and stuff like that. And you will make sure that they work. And probably that is what is done in the automobile industry. Whereas integration testing, you will take the car on a test drive and see how well it fares. And you see a lot of literature and contradictory literature on the internet saying you should do only unit testing or you should do only integration testing. And most of this is just bullshit. You should do both, actually. They are not exclusive at all. Because if you take the example of the prototype car, would you just think about driving the car without having tested each piece? No, because if something breaks, it will cost you too much money. Likewise, you wouldn't probably mass manufacture the car without just having tested the piece and without going on a test drive. And when you think about that, you see that it makes sense to have both. When you do integration testing, there is a new notion of the system under test. The notion already exists in unit testing, but you don't think about that because the unit, the system under test, is the unit. When you try integration testing, then you have to reason about what you want to test. And you can test as small as the collaboration of two classes, or you can test as big as the whole application. Okay? And yeah, you just have to think, when you have integration testing, you can still use the stuff that you will learn in unit testing about the TESTABLE, the dummies, the mocks, everything. But testing is about return over investment. It's not about having the biggest test coverage. I see there are a lot of men in the room. It's not always the biggest. It's only about saving money in the long run. You test only because you think that it is less expensive to write the tests than the bugs you will have in the future if you didn't write the test. And so comes something interesting. It's probably the larger the system and the tests, the more fragile your test will be. And if you have done some testing, and especially some integration testing before, you know that when a test is fragile, it means it gets read for the wrong reason. At some point in time, what happens? You remove it. And so in this case, you spend time writing the test, you've spent time maintaining the test, you've spent time analyzing that the test was not the problem, it was some infrastructure, and so you've lost money. So that means that you should probably think about the system under test on every one of your integration tests. And especially, you should probably organize your tests in a pyramidal way, meaning that you have many unit tests at the bottom, which are very reliable. And the larger the system under test, the smaller the number of tests you have. And not only the smaller the number of tests, but in this case, you should probably only test the nominal path, not trying to check error and stuff. So just test the normal path. With integration testing come some issues that you don't have with unit tests. And the main issues are they are slow, they are fragile, as I said, and they are harder to diagnose because you have a bigger system in the test. Why are they slow? Most of the time, it's because you either use what I call infrastructure resource, might be the database, might be a GMSQ, might be anything related to infrastructure that is not code, but that your application relies on, or a container, like Spring or Java EE. So how can you cope with that? There are not many solutions. Basically, what you will try to do is you will try to isolate your unit tests from your integration tests. Of course, it doesn't make them faster. Yeah. But at least, if unit test fails, it will fail before, and you will fail fast, and you will recover even faster. So how you would separate? It really depends on the build tool. Who here is an end user? Sorry, guys. Who here is a MAVEN user? And who here is a Gradle user? I would say sorry too, but you are too many. Who uses something else? No? Yeah? What do you use? Ah, okay, JavaScript. Okay, I'm sorry, but I'm really a MAVEN user, so I will just talk about MAVEN, but probably you can do the same in your own build tool. What you have to know about MAVEN is you've got this life cycle, and so you have phases, compile, test, and stuff like that, and on every phase, by default, or because you bound it explicitly, you can bind plugin goals. So for example, by default, you've got, on the test phase, you've got the surefire test goal that will get fired. What's surefire? Basically, as I said, it's bound to the test phase, and by default, it will run every test case that is located in SRC test Java or Kotlin or whatever is configured. And if it ends with test, starts with test, or ends with test case. And if you are a MAVEN user, it's very easy. Now you might not know, but basically you have also a MAVEN FAILSAFE plugin. And surefire FAILSAFE is just very easy copy-paste stuff. It's very similar, really. It's really like a copy, and it has different defaults. So it will run stuff that ends with IT like integration tests, or that starts with IT, or that ends with IT case. Now, you might have noticed that in the previous lifecycle diagram, there were not 1, but 4 phases for integration testing, because you have the pre-integration testing phase, perhaps because you want to, I don't know, start up Tomcat. You have the post one, because probably you want to shut down Tomcat. And you have the integration phase itself, and the verify phase. And guess what? We also have the same in the MAVEN FAILSAFE plugin. So the binding is very nice. But it's not by default. So you have to bind them explicitly. And this is one such example. Like here, I bind the integration test goal to the integration test phase and the verify goal to the verify phase. Why do you have at least 2 phases, like integration test and verify? Because probably if you fail your test in the integration test phase, you still want to pass to your post-integration test in order to shut Tomcat. So just think about that. And once this is done, continuous integration is very easy. You can run your unit test at each commit like you do naturally. And so you don't increase the time of the feedback loop. And the integration tests themselves, you can run them whenever you want. It's dependent on your context, like hourly, daily, twice a day, whatever you want. Also think about that some of those integration tests are very reliable, very fast, and probably in this case, they qualify as integration tests, but you still would like to run them in the normal surefire plugin phase. First thing, slow. OK, done. Second one, fragile. And this is because, as I said, your application is not only code. It depends on some stuff, like stupid stuff, the file system. The file system is the first external resource that you might use because you want to read pre-party file, because you want to log files, because the time. Time is also something which is pretty stupid, but it's also qualified as an external resource. The most common and widespread that we reason about are databases. But you also have FTP servers, mail servers, whatever. Whatever your application uses qualifies as an infrastructure resource. And dependent on the nature, there are different techniques for that. Like, for example, if you are coping with time and file system, the first is, if you rely on time, don't get the time inside your class, inject it in your class, so that it will be much easier to test. And if you use files, rely on the newest abstraction of paths instead of using files that are really bound to the file system and that are very hard to test. Next come the databases. Well, if you've done any layer architecture and you wanted to test your service layer, it was quite easy to mock the repository or DL layer. Then you inject them, it's very easy. Now, if you want to test your DLs or your repositories, would you mock your database? Doesn't make any sense. In this case, what you do is you use fakes, like not production grade, but stuff that has the same behavior. Who here is an Oracle database user? No one, 2 people, so I will get very fast. For Oracle database, you have multiple strategies. One of them is that each developer has a single schema dedicated to him. The other is to use Oracle Express, which is not the real Oracle, so you might have gaps. And the final is you use an in-memory database like H2, and it has a nice compatibility mode with Oracle. Just think that the closer you are to your real infrastructure, the better it is regarding the reliability and the trust you can have in your tests, but the more expensive it is. So again, this is trade-off, and you have to think about the context. Another infrastructure resource that we have to cope with are web services, because today, nearly every application uses these web services. And you can reason about, okay, are they hosted or not hosted? There are different ways to think about web services, but mainly it's about technology. So mainly you have only RESTful web services or SOAP web services. REST web services are very, very easy to use. And same technique, you use fakes. How do you use fakes? Well, you can use any framework, very lightweight framework like you want. I found Spark. You probably know some more. And in a very few lines of code, you can have a web server serving your REST resources so that you can test your code against it. Here is an example of a Spark application, and you see that you set the port, so whatever the port of your application will use, and when it receives a get from /hello, then it will return a string. Here you can see that you can also have parameters. Here you can see also that you have response HTTP statuses. Probably what you would like to do is to return a JSON file, so you can read the file and return it here. So in a very few lines of code, you can set up your HTTP server and integration test a port of your application. Quite easy. Problems come with SOAP. Who is using SOAP web services still? Oh, quite a few people. I'm sorry for you guys. Because it's much harder. Of course, you could use Spark again, but the problem is it will be very, very hard to set up, like very hard. And it won't have an effective return over investment. But if you do some, if you have testers in your team, or probably you might also use it, you have SOAP UI. And it's quite great, because it handles nearly every WS specification. You can have headers, you can have whatever you want. And it has a good documentation. It's great. How do you use SOAP UI normally? Well, you get, oh, sorry. They warned me not, oh no. They warned me not about to touch the button, and I did. So you should always, always follow what the guy told you. Anyway, what I was telling is about SOAP. It's very great. And what you would do usually is you would just have the WSDL and create mocks in SOAP UI. And it works. You can have your fakes like that. However, the problem first is to craft the answer, which is very hard to do, especially because most so-called web services are a huge payload, like you wouldn't believe. And the problem is, in this case, how can we run in an automated way? You've got this challenge. I want everything to be automated. I want return over investment. So probably for the response, yeah, it's very easy. You get the response yourself. You copy-paste it into your folder, and you've got the response that you want. You might also tweak it. As far as the automation, you would never believe it, but there is an API for SOAP. and it works really great. Of course, you first have, as I said, get to have the WSDL, and then you've got a whole DSL about doing what you want. And here you can return the SOAP envelope that you want. Of course, this is quite verbose. This is not nice. So I'm afraid that at this point, again, it's about trade-off. Are you willing to integration test your stuff or not? And how much will it cost? How much will it save? Again, it's about context. You might run into little issues. Like you might notice at some point that, that maintaining your integration test suite, it costs a lot. And in this case, please, you should really, really think about keeping things as simple as possible. I have noticed that we have this Pavlov reflex like, oh, duplicating is bad. So everything should be factorized. Most time, this might be true, even it can be discussed, but for tests, probably what you would like is about having the whole context of the test in one file, not in multiple files. Again, it also depends on your team and it's contextual, but I've done this mistake a few times that I try to be smart in my tests. It doesn't work so well. Next is about container testing. Who here uses Spring? Okay, so it's located on the right side of the row. And who here uses Java EE? So it's mainly on the left side. Interesting. And the thing is, so far, we have tested collaboration between classes. We have used fakes to fake the boundaries with the external system. But what about the most important dependency that we use? It's a container. And Spring is a container, Java is a container, application server is a container. You have a lot of containers. So if you make sure that your system under test works very well, but never test in container, you can never be sure. You cannot trust your application. Just to make sure that I have a lot to say about Spring and not so much about Java EE, but the good thing is that there are more Spring users than Java EE users. So the real problem in Spring application is the configuration, the wiring of everything together. That is what you want to test, because you can have your code working normally, then during configuration, a dependency is missing or something like that, you forgot about it, it doesn't work. And you want to make sure that it works quite well. How can you design a testable configuration? You have to think about how you will design your fragment. Probably you will have to decouple your configuration. You won't have one configuration file. You will probably have multiple configuration files. Yeah?
Profiles.
Profiles might be one, but I will be even lower level. For example, I talked about database. In production, you will probably use a GNDI data source coming from the application server if you are doing web application. But for just test, you might want to use, as I said, H2, which won't be provided by the application server. So how do you handle that? You will create 3 fragments. So you will have your main configuration, where you will have the service repository, and the repository will be injected with a bin of type and ID data source. Then you will have one fragment, which will be the test configuration fragment, and you might use, for example, the Apache Tomcat data source, which is quite good, and it will be one connection application, connection, data source, sorry, and here the production configuration, which will be about the JDI stuff. So depending on the context, if you are running your test, you will assemble those two, and if you are running in production, you will assemble those two. In XML, which I don't advise you to use anyway, this might look like this. Like here you have the production fragment, and here you have the test fragment. Here, put this into your buffer memory. I will get back to this later, the max active connection. So how do you put those fragments? Hey, very easily. Remember about MAVEN, you have the main configuration, and here you have the data source config.xml, which will be used in production, and the data source config.xml, which will be used for your test. Done. Some tips about that. The first is to prevent coupling. Also, I did a couple of mistakes, like in one of my XML files, I reference one another XML files and reference a third XML file, and at the end, you don't understand what happens, right? And besides, it prevents reuse. Like I said, I want fragments, and I want independent fragments, so I can assemble them however I want. So I would advise you that the topmost class or application or test class is the one which is tasked to assemble all the fragments, like it would be in your test class, or it would be in web.xml, or whatever. Also, who has never run into this pull exhaustion stuff, like, hey, your application runs very fine, then you put it in production, and at some point your ops call you because, hey, guys, I don't understand this message. We cannot get any more connection to the data source. That's a real problem. You might want to check that it doesn't happen, and remember the max active during your test. This is a good way, so that your connection pool in test will only have one connection. So if at some point your code doesn't release it, you will notice it right away. And finally, as I said, don't use XML. If you are a Spring user, use Java config. It's compile time checking. It's very great. It works very well. How to test now? Hey, guys, Spring provides a module for that called Spring Test. And this stuff is really great because it has JUnit and TESTNG integration. Who knows about TESTNG? Oh, that's good. Who knows about JUnit? More people. So if you start doing integration testing, you should know about TESTNG. For one simple reason. JUnit, like its name implies, is really aimed at doing unit testing. And so let's have this simple scenario that you have an e-commerce shop, and you want to have an integration scenario that goes from login until checkout. So you have login, you have browsing the catalog, you want to put stuff into your basket, you want to do your checkout, and then you want to pay. In JUnit, what you would do in the end is you will have one massive big method with every code you can have in it to do that. And then when it breaks, in your Jenkins or whatever, it will say that there is a failure in this method. How good is that? None, because it's very hard then to analyze and to diagnose where the error comes from. You have to look at stack traces and at your logs, and if they are not done correctly, you are dead. TESTNG, on the other hand, is just about testing. And one of the best features of TESTNG is you can have dependency between test methods, which in unit tests is really bad. You should never do that. But for integration testing, it's really great. So you can break your very big method into having one method per step, login, browsing, and stuff. And then you can make each one depend on one another. And when it breaks, you will know the name of the method, so you will know the step in which it broke, which will make the diagnosis much, much easier. So if you don't know about TESTNG, just have a look at it. It has every JUnit feature plus. Regarding Spring and TESTNG integration, yeah, and that's the reason why Ruby people make fun of us. You can extend abstract TESTNG Spring context tests. Or if you want transactional stuff, you can add a transactional keyword in that. So you just extend this class, and you will have Spring wiring, provided you tell which fragment you want to inject. And this is done through add context configuration. And in this class, you can inject any test class that you want or any bin that you want very easily, because Spring test take care of that. So you extend this class, you say which configuration classes or XML you want to use, you can auto-wire anything, and you use it there. And that makes for a very readable test. Most of the problems we have are regarding the database. The first problem that you will have is, hey guys, we have transactions, so normally you implement them on the service layer through transactional. That's very widespread. The problem is Spring, by default, will roll back transactions. That's the default behavior. And when the test fails, and you have the database state in the same state as the start of the test, how can you know what happened? So what you want to do is not roll back transaction at all. That's also probably why you don't want to use one single schema for the whole integration testing stuff, but probably one schema per developer plus one per environment, depending on where you're doing your test. And this is done, so not rollbacking is done by transaction configuration and putting default rollback equals to false. Also, I don't know if you know about JUnit. Who knows about JUnit? Quite a few people, that's good. JUnit also has the same kind of mechanism that, for example, you can clean what has been done after your test. Again, that's a very bad idea. What probably you should do is to clean before your test, set the state you want, and do nothing after the test. So the database will be left in the exact same state that as if your code, and probably your code, run, and so you can audit the state. Also, it's a mistake I did many times. So here, just set the transaction configuration default rollback to false, and Spring by default won't rollback. Of course, if you still want to rollback at some point, it's possible per method, and setting rollback equals to true. I have a lot more to say about Spring, but we don't have so much time. Just suffice to say that you can also test Spring web applications using this kind of stuff by injecting not the context, but a web app context. Now about our friend Java. Spring lets you inject dependencies in different ways. You can have auto-wiring, like, hey, there is something in the context, and I need the bin of this type, just find it and inject it. I don't like it. I hate it, because it's magical, because you can code something here and it breaks here. Or you can be explicit, saying, I want to inject this dependency into that bin. That's generally what I do. Java EE, through CDI, has no explicit dependency wiring. So it's magical. So whatever is there, is there. And you have the Islander rule, like there can be only one. If it finds none, if it finds two, it breaks. Another problem that doesn't come from Java EE, but comes from the implementations, is that, I'm sorry to tell you, but there are different application servers. And though there is one standard, Java EE, version whatever, it happens that they are not so interchangeable after all. Like mainly in web application, very simple stuff, it works. But let's say that I have done one migration from, it was OC4G, so the very old Oracle application server, to IBM WebSphere, because the application was not portable. So if you have a product and that you guarantee that it works on multiple application server, you probably want to check that it really works. And this can be only done by using it on different servers. So 2 challenges: how to inject and how to deploy. How to inject? Well, basically what you will have to do is, if your application, so your system under test, is very small and your application is very big, you don't want to package everything into your test. You want to deploy only the relevant ports. There is a very good project called SHRINKWRAP that is part of a larger project called ARQUILLIAN, provided by Red Hat, and that does exactly that. Like, you have a DSL to pick and choose the resources you want and to assemble them in the way you want, and to deploy only that on the application server. It has a MAVEN aggregation, and for Gradle lovers, also Gradle. So here is a sample example of SHRINKWRAP, and even you don't know SHRINKWRAP, probably you can understand it like, hey, I will create a war named mywar.war. I will add this class. I will add all the classes that belong to this package. As a webinf resource, I will use the persistence.xml. I will also use some GSPs. As web resources, I will use JavaScript, and I will use this web.xml. And so in this way, you can really pick and choose the stuff that you want so as to constrain, to restrict the scope of your application under test. It's quite great. Yep?
Why do you do this in Spring?
Why would you? No, really, why would you?
No, what is the, okay, so what is that you're doing? Where can you get this in one place like this?
Again, sorry, I don't understand.
You push it so that you get it in one place like this in Spring.
Why, no, again, why would I use SHRINKWRAP in Spring?
No, you wouldn't use SHRINKWRAP.
Okay.
Where do you prefer to configure your test? What this thing is doing to get exactly the...
Oh, for me in Spring, again, I would use fragments. Like, I would cut every dependency, put fragments, like you would do for software normal classes, I would do for configuration, design it, and so use only the configuration I want. And then, if they are not referenced, yeah, too bad, I don't care. But at least it can be, lessen the system under test. Does that answer your question?
Yeah, I guess.
Okay, if it doesn't, just come to me afterwards and we'll chat about that. As I said, it's integrated with MAVEN. So basically, probably your code is dependent on external libraries. I hope you don't reinvent the wheel every time. If you do, that's good. If you don't, then probably your libs are listed in MAVEN. And again, you have a SHRINKWRAP integration that, hey, I will look at your POM, I will import every dependency that has scope of compile and runtime, and I will also have transitivity. And so when you use SHRINKWRAP, like I said, you can create your web archive. You just have a method that is called add as libraries. Also very easy to use. Of course, it's not restricted. You don't need to import every dependency. You can tell only the name, and then because you read from the POM, then it will automatically get the right version. So only having the right only having the right scope under test, system under test is done through SHRINKWRAP. Now about a different application server, I will be much quicker. Basically, as I told you about, this is ARQUILLIAN project that SHRINKWRAP is part of, and it has an abstraction layer to download, deploy, and test your application. And you have many, many container adapters. Probably your application server is on one of them. You have Tomcat, even though it's not a true application server. And it looks very, very similar to the Spring test in the end. The only difference is here, you have the so-called deployment annotation. And it must be a static method. And what it does, basically, is here you have your SHRINKWRAP test. You have your SHRINKWRAP code. So you will create your archive there. It will be the first stuff that ARQUILLIAN does, is to call this method, put it on the application server, and do the stuff. Now, this is an ARQUILLIAN configuration file, and this is to configure every adapter that you have. Like, for example, here, we can see that we are using TOM-EE, and it will bind to the first HTTP port that it finds, and also same for the stop port. And depending on your application server, because this is application server specific, you will do your stuff here. Like, probably here, you will also define your data source if you use any. So this is the end of this presentation. You can follow my blog, you can follow me on Twitter, you can become my friend on LinkedIn. If this talk interested you, you can have a look at the website and the book. And if now you have questions, I will be available for 3 minutes. 3 minutes. Any question? It broke again. No question? Was I clear enough, or was I too boring?
I have one question.
Yeah, good.
If you have to discuss about the trade-offs for integration testing or the return of investment, how do you argue? Because it's hard to get data there if a test will break in the future, or how much implementation will cost.
The problem that you have is we are software engineers. Our trade is very new, and your context is specific. So what you have to do is, I'm sorry, you have to try. It can only be based on empiric experience. Like, you cannot have any value. There are no research paper on that, and probably if there are, they don't apply to your context. So I'm afraid that there is a lot of trial and error involved.
So you do invest and see afterwards if it was worth it or not?
The thing is, how many bugs do you discover in production? How much does it cost? That is quite easy to find out, right? Then you can really have a sum. And if you say, okay, to your boss, okay, let's try, I will spend half this sum and try to improve the situation. And let's see in 1 month if we did some good. What is the return of your investment? Then you might have a good argument for that. Or you can change company. I'm not joking. Yeah.
Like you said that there is like we should roll back integration test to database, but then it will require lots of manual work to check the database state. Is it not like what we are aiming?
You require a lot of work to inject the database.
No, like you want if the test fails, you want to check the database to see what is the state, why it fails, and then that's not the aim of automated tests. You need manual work to do this to check.
Sure, but that's also true for unit testing. Like if a test fails, probably you want to investigate why it failed. So it's not specific.
Yeah, but it's also like if it's like a big company with lots of like different routes, integration routes, and you will have like separate scheme, separate unit, separate like kinds of database for each route. We will end up with like thousands of schemas for separate.
That's why I told you at the beginning that probably your test must be like organized in a pyramidal way. Like probably you have a lot of little unit tests, less small scope integration tests, even less middle scope integration tests, and perhaps 1 or 2 big integration tests that cut through all the layers of your application. But I agree with you, yeah. You cannot, it's return over investment, so you cannot cover everything. You should cover probably what is the most critical to your company. Like, as I told you, if you have an e-commerce shop, probably what is the most critical is the checkout. That's probably what you want to make sure that it never, ever breaks. And afterwards, yeah, again, it's trial and error. I also tried sometimes to have many integration tests, then realize, hey, it doesn't work so well, I spend too much time, it has no return over investment. But then if you go without integration tests, you will also be very sorry. Other questions? It seems that it likes SOAP UI. Yeah?
What do you think about, instead of using integration tests, like using Selenium or something else, like those kind of tools?
Okay, so for me, what is not about Selenium, it's more like about end-to-end testing. Like, that's a very good question. Basically, for me, end-to-end testing is a utmost integration test. Like, you integrate with everything. But my experience in that is that the UI is the most fragile stuff that you have in your application. Because probably some marketer would say, the button here, I would like it red in the lower corner. So if you are using Selenium, you will break your test every time. At some point, I said, Selenium seems like a very good tool. I talked to the business analyst, to the project manager, and told them about Selenium, how to create the test in HTML through the Firefox plugin. And they liked it so much, they created like tens and tens of tests. And then they noticed that they broke every time. So, again, return over investment. In this case, they spent a lot of time creating the test, but even more maintaining the test. And they broke for no real reason, just because one of the customer decided, yeah, let's move the button, let's have another class, and stuff like that. So they are very fragile. There are ways to make them less fragile, like if you use a patch pattern, for example. Anyway, they still get them very fragile. So they must be at the peak of your pyramid, but not lower, and 1 or 2, depending, perhaps 3, depending on the size of your application, not more.
Thanks. And what about, like, you were speaking, like, to mock, like, web services?
Fake, not mock.
Yeah, fake. So what about if your application is made of many microservices? And for example, it's calling like 5 or 6 of them. And let's say if you fake all of these microservices and they have a change, let's say
probably what you would.
How would you like test it like correctly, like for production?
That's a good question. And again, it's about the system under test. Probably in this case, what you should do is have one system under test that is a boundary with one of the microservices each time. So if you have 5 microservices, you will have 5 like boundaries with them, and you will test this little system. And then perhaps have one big one that will try to fake everything to do one nominal scenario, because it's very critical to your business and it cannot fail. But sure, if you go the microservices way, testing will become very interesting. And not only testing. Other questions? Yeah.
How do you reason integration testing and acceptance testing, automated acceptance testing and integration testing?
For me, integration testing is for the engineers, whereas acceptance testing is for the customers.
So you mean development facing and business facing?
I don't know how you are organized in your projects, but what I know is integration testing is like what the car mechanic does to make sure that your car has no problem. You don't care about it. In fact, you don't even know if it does it. So long as your car works, it has no interest to you. And probably if he explains what it does to you, you don't care. So integration testing is for you. Okay, great. I think we are 5 minutes late. So if you have other questions, please come to me. And there are business cards for SAP employees, future one. Thank you very much.